derivation that what we discussed in the previous class. So even though I just given you the general formula which relates between the object distance, image distance as well as the radius of curvature and refractive index. We just deduced the expression as the refractive index of image space divided by image distance plus refractive index of object space divided by object distance, which is equal to difference in the refractive indexes divided by the radius of curvature. So with the base of this formula, we can even move towards the derivation of Lensmaker's formula. Hope you know, my dear students, when we come towards the discussion of lens, we have two different types of lens. One is said to be the convex lens and another one is said to be the concave lens. What happens while we are moving towards the discussion of the image formation by convex and the concave lens? Hope you might have studied the image formation and as well as the position of an image for a different position of an object for the convex as well as for concave lens. So whereas both the lenses are having practical applications, especially to rectify the eye defects like hypermetropia and also myopia. To defect these things we are using the lenses. Then how to utilize those lenses. It plays an important role there. So dear students, you know already that the terminology by the name focal length. That focal length which is going to relate for the convex as well as for concave lens. This focal length exactly gives you the ability of, see why, because I am saying ability, each and every lens is having its own capability of refracting an incident beam of light. So that depending upon that ability and depending upon how much defect that the person is suffering from, so we people are going to design the lens. So it means to design the lens of a desired focal length. To design the lens of a desired focal length, we should need a help of a formula said to be the Lensmaker's formula. Hope in the previous class even I discussed this rear diagram with this Lensmaker's formula. Yes, now we are discussing regarding this Lensmaker's formula. My dear students, even you know this as a lens formula in your 10th standard and you just written it as 1 by f is equal to 1 by b minus 1 by u. Then dear students, now let us discuss how to reduce that formula. This 1 by f is equal to 1 by b minus 1 by u. For that reason, we can use a convex lens for derivation of expression. Similarly, we can make use of a concave lens to derive the expression. But now I am just using a convex lens for my derivation. See my dear students, I am just going to divide the lens into two different parts for my derivation. So I am just going to write a diagram with the help of a complete lens now. See dear students, I am just going to represent this lens by xy. Whereas the lens is having one surface which is curved as well as the another surface is also curved, whereas both the surfaces are convex towards the radar medium. So easily I can say that it is a biconvex lens, simply called as a convex lens. Then now to write a ray diagram, so I am going to consider the optic center which was present to the principal axis inside the lens. Now let us consider an object. Say the object is represented by letter O. The distance between the object and the optic center is considered as the object distance represented by symbol small u. Now the ray of light is going to incident on the first surface of the lens. See, this is the first surface dear students, at this surface, see, I am not considering the second surface, I am just considering the first surface. At this first surface, the light ray undergoes refraction and bends towards the normal because the ray of light is traveling from rarer medium to denser medium. So whereas this medium is called as rarer medium, right? Whereas this medium is also termed as rarer medium, right? Whereas this glass medium or the lens medium is called as the denser medium with the refractive index N. With the refractive index N. Then my dear students, rarer medium is having a refractive index which is equal to 1. See, for the first surface, the ray of light is traveling from rarer medium to denser medium. It bends towards the normal. Assume that the second surface is absent. Then the image formed by the first surface is represented as V1. The distance between the optic center and the object, the image formed by the first surface of the lens is called as image distance. Sorry, I am just writing it as I1. I1 is image. Image distance is represented as V1. Dear students, I1 is an image formed by the first surface. Now, for the second surface, I1 acts as virtual object. See, dear students, the real object is here, but I1 is an image formed by the first surface. Then what about the object for the second surface? For the second surface, I1 is said to be the virtual object. So that after refraction by the second surface, so it forms an image I towards the same side. Whereas I1 is a virtual object for second surface, I is the image for second surface. The distance between the optic center and the image is called as the image distance represented by V. Hope you got all the things, my dear students. I am just going to represent the terms here. So note it down in the notebook where XY is the lens. For rarer medium, refractive index M is equal to 1, and for the lens, the refractive index is equal to N. In the next line, O is the object at a distance of U from the optic center, right? In the next line, after refraction from the first surface, the image is formed at I1 with an image distance V1. And the next line you should write, after refraction from the second surface, that is what? See, after refraction from the second surface, I1 acts as virtual object for second surface, and I is the final image formed by the lens, with the final image distance represented by V. So note it down. So hope you all noted down the points. So just you pause the video and note the points than what I said now. Now dear students, to derive the particular expression, that is what 1 by F is equal to 1 by V minus 1 by V. Here I have the two surfaces, right? So to discuss it in detail, I am going to consider the surfaces separately. See here, refraction through the first surface. Now I am going to consider the refraction through the first surface. Refraction through the first surface. Through the first surface. Yes. 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 Listen. Before going towards the discussion of the refraction through the first surface, I just want to write a formula, general formula that what we discussed. So I am writing it as we know that. See, hope you all written the points that what I said, what is O, what is V, what is I1 and all. So I am just going to write the formula. What's that formula? So the formula is like this. So what is that? The refractive index of image space divided by image distance plus refractive object space divided by object distance, which is equal to difference in the refractive index divided by radius of curvature. So this is what the general formula. Take it as equation number 1. Now let us observe the refraction through the first surface. Yes, I am going to discuss about this. Now I am going to write the first surface. I am not going to write the second surface. Dear students, even you can observe it very carefully. I am writing the diagram. Right? This is the first surface of the convex lens. So whereas the aperture is represented by xy. And now, if I just extend this, I will get a center of curvature. So this is the first surface. So that I will tell the center of curvature as C1. Whereas this is a radar medium with the refractive index L is equal to 1. And this is a medium with the refractive index L. And my students, now this is said to be the pole, right? Because here I just consider the curved surface. I am not considering the entire lens. So here I am just writing it as pole. Now the object is here. Right? The object is exactly placed at this position. Then the ray of light is going to incident on the first surface of the lens. Point of incidence, I want to write the normal, whereas the normal is going to pass through the center of curvature. Then this is said to be the normal. Then the angle between the normal and the incident ray is considered as the angle of incidence, represented by I1. See, we are discussing only for the first surface. Here there is no presence of second surface. Now what happens? The ray of light is traveling from rarer to denser medium. Obviously, the ray of light bends towards the normal. Yes, it bends towards the normal. Yes, bends towards the normal and forms an image said to be I1. Dear students, therefore the angle between the refracted ray and the normal is called as angle of refraction, represented by R1. The distance between the pole and the center of curvature is called as radius of curvature, represented as R1. The distance between the pole and the image is represented as image distance, represented as V1. And the distance between the object and the pole is considered as the object distance, represented as U. This is for the first surface. Then, my dear students, I am just writing the values in case of the refractive index of image space, in case of refraction to the first surface, and also what is the image distance, what is the object distance, what is the refractive index of object space, and radius of curvature. And also I am just going to apply the sign conventions. Dear students, please be careful. So I am going to run this diagram after the completing of that diagram. So just you should be very careful. You should remember that diagram for the next discussion. So what I am doing, I am just going to note it down the points which is present in this diagram. So I want to write the refractive index of image space as well as refractive index of object space, as well as even I want to mention the object distance, and I want to write the image distance, and next I want to write the radius of curvature. Radius of curvature, yes. Now for the first surface, you can observe that what is the refractive index of the image space. So it means where the image is present, image is here. So it means image is here, it means image is inside the glass medium. Then what is the refractive index of this image space? Where this is the refractive index of the space where the image is present. That is N. So it is represented by N. The next thing is refractive index of object space. Object is here, it means object is in the radar medium. Then what is the refractive index of this? So it is written as 1. Yes. Next thing is object distance. Object distance is U, as well as what is the image distance which was given here? It is V1. And what is the radius of curvature? It is R1. See, my dear students, we just return the values. But still we have not applied the sign conventions. Hope you all remember the sign conventions. So that according to the sign convention, all the distances should be measured from the pole along the principal axis. The distances which are measured that is towards the direction of incident rays taken as positive, and the distances which are measured opposite to the direction of incident ray is negative. And my dear students, a real object and the real image distance is taken as positive, and the virtual object and the virtual image distance was taken as negative. Here you can observe that the pole is here. The incident ray is towards the direction of x-axis, that is what the positive x-axis. Then the R1, that is what the measurement of the radius of curvature from the pole, and the measurement of the image distance from the pole, both are along the direction of incident ray. So then R1 and V1 are positive. So it's clear now. R1 and V1 are positive. And there is no case of sign convention for refractive index, so we are not considering that. Then we are measuring the object distance opposite to the direction of incident ray. Incident ray is towards the positive x-axis, whereas we are measuring it in object distance in opposite direction. So that U becomes minus. U becomes minus. Hope you got this? Right. Now, let us apply this in the equation number 1. So substituting the above values in equation 1. So let us see what we will get. So, or refractive index of image space by image distance. Refractive index of image space is N divided by image distance is V1. Next here plus refractive index of object space by object distance. So 1 divided by minus U, so it is minus 1 by U, which is equal to difference in the refractive index. We have two refractive index N and 1. So let us write the difference of those two refractive index as N minus 1 divided by the radius of curvature, that is R1. Take it as equation number 2. Take it as equation number 2. Okay, my dear students, just we observe the refraction through the first surface. Similarly, let us observe the refraction through the second surface. Okay, refraction through the second surface. So here due to the shortage of space, I am just going to write it and I am doing. So you should write it again. So that I am going to write the second surface here. This is said to be the second surface. I am just going to write the second surface which was present. Now let us write the principal axis, represent the pole. If I just extend this, I will get a sphere. So it is having a center of curvature C2. The distance between the pole and the center of curvature is called as the radius of curvature, represented as R2. Now, what is an object? Dear students, already I said, first surface formed an image said to be I1, whereas this image I1 serves as virtual object for second surface. It means which one is an object for the second surface? I1 is an object for second surface. So already the I1 is present here. So mole and I1 is V1. See, please be careful. I1 is virtual object. So at the point of incidence, I am going to draw the normal. So whereas with an angle of incidence, see my dear students, it is going to incident with an angle of incidence that is said to be I2, right? So now it is going to undergo refraction, whereas the light ray is traveling from denser medium to rarer medium. Because this medium is said to be the rarer medium with a refractive index n is equal to 1, and whereas this medium is said to be the glass medium with a refractive index n. Then the ray of light, the incident ray of light, is going to bend away from the normal. So it bends away from the normal and forms a final image at I. So whereas the angle of refraction is R2. The angle of refraction is R2. R2 is an angle of refraction which is present between the normal and the refracted ray. The distance between this P, that is pole, and the image I is said to be B, that is called the image distance. I am repeating again. R2 is the radius of curvature. V1 is a virtual object distance because I1 is a virtual object for the second surface, and V is the image distance for the second surface. See, please note this formula somewhere else. So I just want to leave this formula. So I just want to leave this formula and I am going to substitute all these things here. So let us see. So you should write it again. Very well. So now here the refractive index of image space. Where is image? Image is here. Right? The image is here. So it is a refractive index of the image space. The refractive index of the image space is here. So my dear students, you should be very careful that the refractive index of the image space, where it is, the image is in the rarer medium. So the refractive index of this one is taken as 1. And you can observe carefully, where is the object? So when we come towards this case, here the object is said to be the virtual object, no problem. Then where is an object? So by saying this man, the object is exactly in the rarer medium, so it's wrong. Why? Because for the first surface, we assume that the second surface is absent. See, for the second surface, we assume that the first surface is absent. But from where the light ray is coming from? So the where the light ray is coming from? So it is coming from the first surface. It means here you can observe that it will refract ಆಗಿರುತ್ತೆ. So it refract ಆಗಿ ಇಲ್ಲಿ fall ಆಗ್ತಾ ಇರೋದ್ರಿಂದ already the light ray which is refracted by the first surface is going to fall on the second surface. It means where the object is, it is in the denser medium. So I just shown the incident arc here. So the virtual object is in the denser medium, that is written as a N. Right. Now these two things are concluded. Next, what is an object distance? The object distance is V1. And what is the image distance? Image distance is V. What is the radius of curvature? It is R2. Simply we written all these things, but still we should apply the sign convention. See, we are measuring the image distance and also the object distance. We are measuring the object distance in the positive direction. That is what, along the direction of incident ray. Incident ray is in this direction. We are measuring V and V1 in the same direction. So both are positive. No problem. Then we are measuring the radius of curvature in the opposite to the direction of incident ray. So that R2 becomes negative. And one thing you should remember, here if real, I said they are according to the sign convention, real object and real image distances are taken as positive, and virtual object and virtual image distances are taken as negative. Here I1 is to be the virtual object, so that the virtual object distance is taken as minus V1. Hope you got this. So how to apply the sign convention? So it becomes minus V1. Now let us apply all these sign conventions in the equation number 1. So it is like refractive index of image space by image refractive index of the image space is 1 divided by image distance is V. Next, plus refractive index of object space by object distance. So that refractive index of object space is N divided by the object distance. That is what is the object distance which was given here? That is minus V1. So here it is minus N by V1, which is equal to difference in refractive index. We have two refractive indexes, 1 and N. So difference in the refractive indexes can be written as N minus 1 divided by radius of curvature. What is the radius of curvature? It is minus R2. Take it as equation number 3. My dear students, now we just come towards the writing up of the three equations. That is what the equation 1, equation 2 and equation 3. But still we not yet derived the expression for Lensmaker's formula. Now let us continue this. So we have two equations, right? Have two equations here. Yes. I am going to add both the equations. Adding equation 2 and 3. Right? Now let us see what we will get. We get, yes, I am adding it. So towards the LHS, we have N by V1 minus 1 by U. N by V1 minus 1 by U plus 1 by V minus N by V1. I just added this LHS term with this LHS term. Now remaining is the two RHS terms for both the equations. I am adding those two things, which is equal to N minus 1 by R1 minus N minus 1 by R2. Why? Because we should add this. So plus, here it is minus R2. So plus into minus becomes minus. So I directly write it as minus. Right. Now, N by V1 minus N by V1 cancel with each other. Then remaining is 1 by U plus 1 by V, which is equal to, which terms are common here? N minus 1 common. So that remaining is 1 by R1 minus 1 by R2. Yes, dear students, I am rearranging this. So it becomes 1 by V minus 1 by U. So we got finally the expression, that is what? 1 by V minus 1 by U is equal to N minus 1 into 1 by R1 minus 1 by R2. So you can observe the equation very carefully, that, my dear students. In that equation, we came to the conclusion that it is having a relationship between refractive index, radius of curvature of the two surfaces of a lens, object distance and image distance. Then, still we should move for focal length. So, 1 by V minus 1 by U. See, my dear students, we know that 1 by V minus 1 by U is equal to 1 by F. So that F is said to be the focal length of a lens. So that in place of 1 by V and 1 minus 1 by U, I am substituting 1 by F. So 1 by F is equal to N minus 1 into 1 by R1 minus 1 by R2. So finally we got an expression that 1 by F is equal to N minus 1 into 1 by R1 minus 1 by R2, where F is a focal length. So this formula is called as the Lensmaker's formula. This is one of the important formula which you will get in your examination. So not only the Lensmaker's formula, even we can call this one as Newton's Lensmaker's formula. Yes. Now, see, I just kept the equation as it is. Otherwise, I will write the equation again. So, I am just going to write the equation over here. 1 by F is equal to N minus 1 into 1 by R1 minus 1 by R2. This is what Newton's Lensmaker's formula. Then, by seeing that equation, now let us move towards on what factors does the focal length difference. formula 1 by f is equal to n minus 1. Whereas n is a refractive index of a lens, 1 is a refractive index of a surrounding medium. So then, suppose if we have water which was surrounding a lens, then it is not proper to write exactly n minus 1. Why? Because n is a refractive index of lens and 1 is a refractive index of the radar medium which was surrounded the lens. Suppose if the water is covering, we should write the refractive index of water in place of that 1. Then here the f is depending upon n, right? F is depending upon the refractive index of a lens. F is depending upon the refractive index of the medium surrounded by the lens. So that I am writing it focal length. It depends on. So it depends on the refractive index of the material of the lens, with which material that actually was prepared. And the next thing is, so I just tell you that it depends on the refractive index of the surrounding medium. Surrounding medium, whether it may be a water, it may be the air, it may be the vacuum, so it is depending upon that. So as well as, so here in this equation, this focal length is again depending upon the radius of curvature. So that it depends on the radius of curvature of the two surfaces of a lens, So on these factors the focal length depends on. Not only that, my dear students, suppose if I perform the experiment, that is what the refraction experiment by using the lens with the help of white light, so the phenomenon is different. Suppose if I use a red color light, the refraction is different. Suppose if I use the violet color light, the refraction is different. Why? Because even you might have studied the same thing in your 10th class. That is what, suppose if a prism is present, then what actually the prism is going to do? The prism is going to show the different angle of deviation, as well as prism is going to show the different refraction, as well as prism is going to show the different angle of the banding of the different colors of light, as well as it finally shows the dispersion effect. So dear students, I am repeating again. So similarly to that of a prism, I am just moving towards the discussion of which, that is what, the refraction through the lens also. Dear students, the lens when we come towards, that is what, when we come towards the discussion of a lens, it may be the convex or even it may be the concave lens. So finally we deduced the expression for the focal length. In that formula we observe that we have n, r1 and r2. No problem with that, we just noted out the 3 points, but with that even we can write that it is depending upon the wavelength of light used. Suppose if I use a red color light, the refraction changes, that is what the bending changes, the focal length changes, the focus point changes. So as well as you can easily say that the power of the lens is also going to be adjusted with respect to the different colors, so that different colors can be exactly termed as a wavelength. It depends on the wavelength of light used. Yes, these are all the 4 points on which the focal length depends on. Then suppose here I just written the formula, that is what, 1 by f is equal to n minus 1 into 1 by r1 minus 1 by r2. Whereas here I just placed the lens in an air medium, right? So I just placed the lens in an air medium and I performed an experiment. So that I got n minus 1. Suppose if I perform the experiment by placing a lens inside the water, what happens? See, actually there was a question related to this. If a lens is kept inside the water, when the lens, at what time, at what condition does the lens becomes invisible? So you should be very careful that if the refractive index of one medium is similar to that of the refractive index of another medium, then we can say that one medium is invisible in another medium. So that is what ಎರಡು medium ಕೂಡ refractive index same ಇತ್ತು ಅಂದ್ರೆ ಎರಡು medium same ಆಗಿ ಕಾಣುತ್ತೆ, different ಆಗಿ ನಮಗೆ ಕಾಣಲ್ಲ. Similarly, lens ನ water ಒಳಗಡೆ dip ಮಾಡಿದಾಗ, so you know that water is having a different refractive index said to be 1.3 and glass is having index said to be n. Here it is having a refractive index said to be n. That is what 1.5. Glass ಗೆ 1.5 ಇರುತ್ತೆ, water ಗೆ 1.3 ಇರುತ್ತೆ. Then dear students, ಹಾಗಾದ್ರೆ ನಾವೇನು ತಿಳ್ಕೋಬೇಕು ಅಂದಾಗ, so lens separate ಆಗಿ ಕಾಣುತ್ತೆ, water ಕೂಡ separate ಆಗಿ ಕಾಣುತ್ತೆ. Then ಯಾವಾಗ ನಮಗೆ when the lens becomes invisible inside the water, when it will become invisible, when the refractive index of that glass, when the refractive index that lens becomes equal to the refractive index of water. ಎರಡರ refractive index ಯಾವಾಗ ಸೇಮ್ ಆಗುತ್ತೆ, ಯಾವಾಗ ಈಕ್ವಲ್ ಆಗುತ್ತೆ ಅಂತ ಟೈಮ್ ಅಲ್ಲಿ ನಿಮಗೆ lens water medium ಅನ್ನು ಪ್ಲೇಸ್ ಮಾಡಿದ್ರು ಕೂಡ we come to the conclusion that the lens is invisible. So you please be careful that the lens becomes invisible when it is kept inside the water. That is only when the refractive index of a glass medium becomes equal to the refractive index of water medium. Not only that, so if you know the focal length, then even we can discuss what the power of a lens. So I just want to give the definition of power of a lens. Dear students, the power of a lens is represented by the symbol P, right? See, we can define the power of a lens in 2 or 3 ways. So you can use any ways to define it. So but simply you can define that power of a lens is said to be the reciprocal of focal length. That is what P is equal to 1 by F, right? What is the SI unit of the power? You know that the focal length is having an SI unit meter. Then what is the SI unit for power? That is said to be per meter or meter inverse. Rather than writing meter inverse, SI unit for power is diopter. Then define 1 diopter. 1 diopter is the power of a lens. With focal length of 1 meter. With focal length of 1 meter. This is the definition for 1 diopter. That is what the SI unit for power. Here we have power, right? If I want to write the power is 1 diopter, I want to substitute that focal length as 1 meter. Right? Then only I will get 1 by 1 is 1. Otherwise, I will get different values. So 1 diopter is easily defined as the power of a lens with focal length of 1 meter. So in the previous class, I said the focal length of convex lens is positive. Similarly, the focal length of concave lens is negative. Then what happens to the power? It's the same thing. That is what the power of a concave lens is negative and the power of a convex lens is positive. Then the definition of a power can be simply defined as it is an ability of a lens to convert or to divert the incident beam of light. If we use a convex lens, it converts the incident beam of light. If we use a concave lens, it diverts the incident beam of light. And I can easily say that the power of a lens is defined as the ability of a lens to convert or to divert the incident beam of light. This is about the power of a lens. Okay, dear students, shall we just discuss the power and the focal length. So whereas power, even it can be defined by using a diagram also. That is what, just by using convex is having an optic center said to be O. Then even it is having a principal focus F. If I incident a parallel beam of light, then what happens? It refracts and passes through the principal focus, which is having a focal length F. So whereas this is the direction of incident ray, but it deviated to an angle of theta. Then if I just write the perpendicular here, that is what is said to be the height. Whereas this angle is also said to be theta according to the mathematics. See, I said power of a lens is the ability of the lens to convert or to diverge the incident beam of light. But here you can observe that the convex lens is the one which is going to converge the incident beam of light with an angle say theta. My dear students, whereas it's an ability of convex lens to converge, it's an ability for concave lens to diverge. So that the power is positive for the convex lens and the power is negative for the concave lens. And one thing you should keep in your mind that even we can discuss the power of a lens with the help of tangent. So let us discuss that definition in the next class. So till now in this today's class we discussed the derivation of expression for Lensmaker's formula, and the formula is 1 by f is equal to 1 by v minus 1 by u, that is said to be the lens formula, and the Newton's Lensmaker's formula can be written as 1 by f is equal to n minus 1 into 1 by r1 minus 1 by r2. And finally E1, we just discussed that on what factors does the focal length of a lens depends on, and what happens if we dip a lens inside the water, and even we discussed the definition of power of a lens and how that power is again can be defined with the help of SI unit, that is said to be diopter. Hope you are all taking down the notes, and please be careful, and each and every day by the completion of the same day itself you should go through the concepts and write it in your notebook once you just work it out in your rough book also. Thank you.